Okay, so hi everyone. Today we're going to be discussing the final paper in our set. Okay, and this is the final class lah. Okay, for our physics session, which is the Kedah paper 2 section A. Okay, and then when I was going through this paper, I realized that actually the Kedah paper is very similar to the Terengganu paper. Banyak soalan yang sama lah. Okay, but in any case, we will go through it. And after that, I want to go through one extra question which has been asked to me quite a lot of times by different people, different teachers and students. I don't know which paper this is from, but later we'll talk about it lah. Okay, at the end of this paper 2 thing. Okay, so this is the Kedah paper. Diagram 1 shows a velocity v against time graph for moving motorcycle. Okay, so we've discussed before what are the important things in the VT graph. Okay, remember that in the velocity time, you need to think about the gradient, okay, and also the area under the graph. Okay, di mana the gradient represents the acceleration, okay, and the area under the graph represents the distance traveled. Okay, so don't forget these two important things when we're talking about VT graph. If it is an ST graph, then only gradient lah. Gradient represents the velocity. But this is a VT graph. So underline the right under velocity is the rate of change of course, we are talking about velocity, so the answer will be displacement. Okay, kalau dia adalah distance, it will be speed. Okay, because speed and distance are scalar quantities, velocity and displacement are vector quantities. Okay, now tick on the base quantity that is shown by the graph. So of course it's time lah. Okay, just to remind you that the base quantities are time, temperature, okay, mass, current, okay, intensity. Yeah, there's one more. So I can't remember what it is. Oh, length, sorry. Okay, all these are base quantities lah. So time, length, temperature, mass, current, and intensity. I think there's one more, but not really sure. Can't remember. Amount of substance. Amount of substance. Maybe lah, maybe. Okay, name the physical quantity that is shown by the gradient of the graph. So the gradient of graph again lah, okay, is acceleration. Okay, because this is a VT graph, okay, so the acceleration is denoted by the gradient of the graph. So the answer in B2, which is acceleration, is a quantity vector. Give another example of a quantity vector. Sorry, of a vector quantity. So there are many examples lah, okay, of vector quantity. Just remember that vector quantity has not just magnitude, but it also has direction. Okay, so it can be force. It can be, actually you can even repeat the distance because dia mau selain daripada acceleration bahkan. So you can actually say displacement. Okay, you can say velocity. Okay, or you can say momentum. In case you're afraid of saying, like you want to repeat this answer, right? Padahal it's already given in the beginning. I don't think it's an issue lah. Okay, I think you can just write displacement or velocity lah. Okay, but these are very basic questions. Vector quantities, of course, don't forget the opposite of it is scalar quantities lah. Okay, scalar quantities are quantities which have magnitude but no direction, mass, time. All these are scalar quantities. Okay. Diagram 2 shows an advertising board held by a light iron rod, and wire to a vertical wall of a building. The iron rod is fixed horizontally. Okay, so we'll take a look at this one, fixed horizontally. That wire is here, okay, and it makes a 30-degree angle with the iron rod. Okay, so name the force F. Okay, because this is a wire, okay, so it will be tension. Okay, string, wire, anything that is pulling, okay, will always have a certain tension over there. Okay, so draw the vertical component, okay, Fy. So vertical is very easy, but of course the important thing is remember that the vertical and the horizontal force always is from the starting point of the force. So since the force is going in this direction, the starting point is here. Therefore, the Fy will be here. What you want to avoid now is to avoid, oh, the F is here. Okay, so the Fy will be here. This is wrong. Okay, because the vertical, when bila kita leraikan daya, when we resolve the forces, okay, it must always start from the point of the beginning of the force, not where the force is going, but where the force is coming from. Okay, so the Fy will be here, and if they ask you to draw a horizontal component, this will be the Fx lah. Okay, always from the same starting point. Okay, look at the direction of the force. That will help you lah. If the force is going this way, for example, okay, then this will be down and right. Fx will be down and Fy will be, Fy will be down and Fx will be right. So everything depends on the direction of the force. Okay, don't forget that. Okay, now if the mass of the board is 50 kg, the answer is there. The weights of the iron rod and the wire are ignored. Calculate the force F. Okay, so if the mass is 50 kg, that means you have a weight over here. Okay, we can count the force by considering this. So actually Fy is equals to F sine 30 bahkan. Okay, because it's a horizontal component. The vertical component is touching the 30 degrees. So the touching one is cos. Okay, Fx cos. And since this is Fy, it will be Fy sine 30. And since this is in equilibrium, okay, it is not stated but we understand it to be is in equilibrium, it's not moving. Okay, so since it is not moving, means that the weight, okay, must be equals to Fy. So that means F sine 30 equals to mg. Okay, you can start from that point lah. Hold on. F sine 30, okay, equals to mg because Fy is equals to mg lah. Okay, so so then you can calculate this now. F sine 30 I think is 0.5. Okay, m is 50 and then g is 9.81. Okay, so you get about 981 newtons. Okay, so again, we see this question quite a lot this year. Okay, equilibrium of forces lah. Okay, so it may be a good idea for you to just brush up on equilibrium of forces, how to resolve the forces into two components, the horizontal and the vertical lah. Okay, tapi yang paling penting is whether it is sine or cos depends on which component the angle is touching. Okay, if the angle is touching the horizontal one, then the horizontal one is cos. Sebab kita selalu ingat cos is adjacent over hypotenuse bahkan yang bersebelahan dengan dia. And so better to remember it this way. So if let's say for example, okay, let's say the angle is here lah. Contoh lah kan. Okay, the angle is here. And this is 30 degrees. So that means my Fy will be F cos 30. Why? Because the 30 degrees is adjacent, is next to the Fy. Okay, so let the angle help you. Okay, let the angle help you to know whether it is sine or cos. Kita pegang saja kepada ini. So and ka lah. Kalau yang opposite is sine. Kalau yang tidak bersentuh, itu yang sine. Kalau yang bersentuh, itu yang cos. Okay, so it's easier for us to remember rather than okay, I must remember if the sine, if the mendata one is cos and then the menegak one is sine. But ada syarat lagi, the angle must be here. Just remember the SOHCAHTOA lah because we've learned this SOHCAHTOA since Form 3. Okay. Right, number 3, diagram 3 shows the Earth-Moon system. The Moon orbits around the Earth once in 27.3 days. Okay, the distance between the Earth and the Moon is given as this lah. Given the mass of the Moon is 7.35 times 10 to the power 22. Okay, first determine the linear speed. Linear speed formula is given over here, 2 pi r over t. Okay, the t is 27.3, but remember that we have to change this into seconds. So it's 27.3 times 24 times 60 times 60. Okay, sebab the first one is tukar kepada jam, second one is tukar kepada minute, and the third one is changed to seconds. Yeah, I know, sorry. Because our unit is meters per second. Okay, so we have to change the days into seconds. R is given as this, so this is not a problem lah. Okay, so 3.84 times 10 to the power of 8. Okay, times 2 times pi over 27.3 times 24 times 60 times 60 lah. Okay, change kepada seconds. And you will get the answer 1023.04 meters per second. Okay, in this one, the formula for linear speed is given, okay, but it is given macam ini, which actually you can also use lah. Okay, sorry, hold on, linear speed. Yeah, okay, you can also use this formula for linear speed, gm over r, because you have the mass and you have the r. Okay, but the reason why I use the 2 pi r over t is because of Kepler's third law. Okay, I combine this one and this one lah. Okay, in order to use 2 pi r over t. But actually, I think if you use this, you will get the same answer as well, because you have the mass of the moon, the value of g. Oh, the value of g is given. Oh, the value of g is not given. Okay. Yeah, I guess if the value of g is not given, then it's a little bit difficult lah. Unless you remember lah, 6.67 times 10 to the power of negative 37. I think so. I think so lah. Okay, but either way, there are more than one way to determine the linear speed of the moon. Okay, so there is one that involves this one. Okay, and then another one is this one. Tetapi ini tidak akan diberi lah. Okay, this is actually given in the textbook, but it wouldn't be given in the formula list because it's a very uncommonly used formula lah. Okay, so it may be a good idea to memorize this if you want to use this. Okay, but if you don't want to use this, you want to use this formula, then you have to memorize the value of G. Which is very strange lah. Sepatutnya G diberi dengan kamu, tapi dia tidak bagi. So strange. Okay. Determine the gravitational force. The gravitational force is the centripetal force. So mv squared over r. Okay. Again, m is the mass, not the mass of the moon. Okay. Sorry. Yes, the mass of the moon. Sorry, mass of the moon 7.35. Because centripetal force ini mass yang kita kira. And every other formula is always the center punya mass. But centripetal force, mv squared over r, okay, the mass that we use is the mass of the thing yang berpusing. Okay, itu saja yang berlainan. Everything else we use the center punya mass, kecuali centripetal force. So mv squared over r, you have v from question number 1, which is 1023.04 meters per second. Okay, then you square it lah. Okay, over r, r is also given as 3.84 times 10 to the power 8 ini. Okay, so everything is given there. You calculate, you should be able to get about 2.003 times 10 to the power of 20 newtons. Okay, so this is a tricky question because you need to understand that the gravitational force on the moon by the earth is also known as the centripetal force. Okay, because if you want to say the gravitational force between the two objects, selalu orang akan fikir this formula F equals to G m1 m2 over r squared. But the problem is you are not given the mass of the earth here, you're only given the mass of the moon. If you are given the mass of the earth, then you can use this. Okay, you will get the exact same value. Okay, kamu akan dapat nilai yang sama. But the problem with this question is they didn't give you the mass of the earth, they only give you the mass of the moon. So you have to remember that, oh, okay, I have to use centripetal force because only one mass is given. Two mass are given, you can use the Newton's gravitational universal law of gravitation punya force lah, punya formula lah. But if it is centripetal force, if you're only given one mass especially, okay, and the mass yang diberi adalah mass yang sedang berpusing, bukan mass yang di tengah, then you have to use centripetal force. Okay, which makes this question, okay, this question At first glance, it looks like it's an easy question. Okay lah, calculate the linear speed, got the formula in front ma, but no value of g. And then calculate the gravitational force, also got the formula in front, which is this. Okay, but the problem is you don't have the mass of the Earth, unless you happen to memorize the mass of the Earth. I guess if you memorize the mass of the Earth, then you can use this formula lah, but you will get the same value. So this question is difficult because we have to learn to be flexible with the formulas. Okay, and of course the problem with gravitation is that there's so many formulas lah. Okay, there's so many formulas, and it's like and they kind of overlap one another. So we want to be careful with that lah. Okay, the moon does not move closer to the Earth, even though the gravitational force acts on it. Okay, so I didn't want to waste time, so I gave the answer here. Gravitational force causes a centripetal acceleration. Okay, this is the first point. The centripetal acceleration changes the moon's velocity in terms of its direction. So I want to qualify this. The linear speed remains the same. Okay, so the linear speed, okay, is the same. But the velocity is different because we are changing the direction of the moon. Sebab kita selalu berpegang kepada if there is an acceleration, then there is a change in velocity. Okay, saya ulang balik. Kalau ada acceleration, means the velocity is changing. But for us, we always think that increasing velocity, right? I always say this, increasing velocity equals to acceleration. Okay, which is true lah, which is true kalau dia adalah bergerak on a straight line. But now the moon is moving in an orbit, in a circle, with the same linear speed. So what is changing? Why is there an acceleration if the linear speed is the same? Because the thing that is changing now is the direction. So one thing that we are not very, that saya tidak berapa tekankan lah, is changing direction. Okay, a change in direction also equals to acceleration. Kalau salah satu daripada syarat ini dipenuhi, bahkan means akan ada acceleration. Okay, cuma in the case of the moon and the earth, the speed is the same. Dia punya kelajuan adalah sama, but because the direction is changing, therefore we say that the velocity is also changing, which means that there is an acceleration. Okay, so gravitational force causes centripetal acceleration, first point. It changes the moon's velocity in terms of the direction only, second point. Okay, the third point is optional lah. Kalau tidak mau tulis pun tidak apa. The moon moves in a circle with a constant speed. Because once you write the direction sahaja yang berubah, we understand now that the speed is constant. Okay, so this is the thing that is different about chapter 2 and chapter 3. Chapter 2, everything is moving in a straight line. So kita tidak berfikir pasal perubahan arah, kita hanya berfikir pasal perubahan kelajuan. Tapi in gravity, when something is orbiting, the speed may be the same, but the velocity is still changing because the direction is changing. Dia bukan kiri atau kanan, dia adalah berapa degrees. So the direction is always constantly changing. That's why there is an acceleration. Okay, come back to the original concept of acceleration. Acceleration is the rate of change of velocity, and velocity ada dua component, which is speed. Which is the magnitude, the speed, and the direction. Salah satu daripada ini berubah, akan ada acceleration. Okay, very classical physics. Okay, number 4. Researcher conducted an investigation using phosphorus 32 to study the absorption and movement of fertilizers in the plant. Okay, so diagram 4 shows how the radioisotope phosphorus 32 is injected into the stem of the plant. Okay, the half-life of phosphorus is 14 days and emits beta particles only. Wow, so nice. Okay, beta particles. So what is meant by the half-life? So half-life always starts with time taken lah. Okay, for activity of radioactive substance to reduce to half, okay, of its original value. Okay, atau yang sewaktu dengannya lah. The idea is that time taken, activity, half original value. Okay, reduce to half lah, or become half of its original value. Okay, that's the half-life. So the initial phosphorus 32 activity is 800 counts per second. Okay, calculate the time taken to decrease to 50 counts per second. So the activity originally is 800. So every half-life, it will become half lah. 400 will become, jangan juga kamu cakap kosong lah, half. So 200. Half of 200, 100, half of 100 is 50. Okay, which is our final destination. So di sini ada 1, 2, 3, 4 half-lives. Okay, every half-life is already given as 14 days. So 4 half-lives means 56 days loh. 14 kali 14 days times 4 half-life. Okay, which will give you 56 days. Okay, so this is a pretty standard step lah. Start with the original activity and then kasih half until the last activity. Then you count how many half-lives there are. Okay, a small pond nearby a nuclear reactor becomes contaminated by the release of radioactive waste. So the radioactivity of a sample of the contaminated water from the pond is tested for 5 minutes, and the result is shown in the graph below. So this is obviously a half-life graph lah. Okay, this is a half-life graph. Now, use the graph to find the half-life. Show clearly on the graph how you obtain your answer. So this is a 2-mark question. Okay, so half-life is the time taken for original become half the time. So 800 is the original, half of it will become 400. So you have to use your ruler, draw the line, okay, and then come here lah. So on your paper, it may be a little bit smaller, okay, but to us, sorry, for me, okay, at least for me over here, it's quite clear lah, that this is 1.2 minutes. Okay, 1.2 minutes. So you want to write down there 1.2 minutes. Okay. Now the radioactive source does not pose a danger if it has decayed to 1/8 of its original activity. Calculate the time taken for 1/8. Okay. So 1/8 of its original activity, radioactivity is 1/8 times 800 lah. So we want to go to 100. And 1/8 of 800 is 100. So we start with the same thing, 800, and then we divide our way until we get 100. So 400, 200, 100. So it's 1, 2, 3 half-life. So if 1 half-life is 1.2 minutes, 3 half-life will be 3.6 minutes. Okay, so it's basically repeating the same thing as we did just now. Okay, except that now they are involving the graph lah. Kalau kamu punya half-life di sini salah, then everything will be wrong lah. Okay, sorry, this number 2 question will be very hard to get full marks lah. Okay, so be very careful when you're dealing with a decay graph like this. Oh, sorry, when you're dealing with a decay graph like this. Okay, make sure that you know what is the original activity, and then you calculate the time for it to become half of the original activity. Okay. Now, if the sample of the contaminated water used in the test is of a smaller quantity, okay, what happens to the value of the half-life? So we have a what happened question lah. Okay, so what happens question, always 3 possible answers. Either the half-life will increase, or the half-life will decrease, or the half-life will remain unchanged. Okay, always these 3. So watch out for this question lah. This kind of question, what happens? Generally lah, secara amnya, what happens question will have one of these 3 answers. So even if you don't know, just tembak lah. Okay, don't leave the answer kosong. Okay, but of course, in our case here, the value of the half-life will remain unchanged, because half-life doesn't depend on how much your radioactive sample is. It depends on the radioactive sample itself. Okay, dia bergantung kepada jenis bahan radioaktif. Bukan bergantung kepada berapa banyak ini. So even if let's say if let's say I have 1 kilogram of this one or 1 gram of this one, right? The time taken for 1 kilogram to become 0.5 kilogram and for 1 gram to become 0.5 grams, the time taken, sorry, the half-life, the time taken is always the same. Okay, and this is a very strange thing for us to understand because we always think that, oh, if there is more, means it will take a longer time to become half lah because there's more and it's very logical. Kan? 1,000 gram become 500 gram. How can be the same time as 1 gram becomes 0.5 gram? That's why this is not really under classical physics lah. Okay, because it doesn't, we cannot brain this lah. Okay, we cannot really brain this because, we have to understand that again, this works at the molecular level. And things at the molecular level kan, dia adalah dunia yang sangat berlainan. Macam di angkasa lepas. It is also a different world in itself. And we said just now, gravitational force actually also is centripetal force. The linear speed, so it's a very different setting than what we are used to on Earth. So we cannot think that way. Kita tidak boleh fikir, oh kalau 1 kilogram kan, mesti dia mesti dia lebih lama. No, it doesn't work that way. Okay, molecule hanya tahu, oh kamu adalah uranium, begitulah kamu punya half-life. Okay, kamu adalah plutonium, begitulah kamu punya half-life. Doesn't matter how much plutonium or uranium you have, the half-life always remains the same. Okay, be very, very careful with this. So this is a very good question. It's a trick question. Don't be tricked by it lah. Okay, kalau kamu kena tanya. Diagram 5.1 shows 4 pendulum bobs, okay, of different lengths tied to a string. In case nobody asked this is called Barton's pendulum. Okay, and Barton's pendulum, dia ada kaitan dengan resonance. Okay, the easiest way to remember this is that these two, since they are the same length, will oscillate with maximum frequency. Okay, B lah. B will oscillate with maximum frequency. It doesn't mean that A and C dia langsung tidak bergerak. No, that's not the case. A and C will also move, but it's moving very little because the original one and B is the same length. So the word maximum amplitude. Maximum amplitude must be there. Okay, you cannot say that B will oscillate with amplitude. No, B will oscillate with maximum amplitude. Okay, adakah A and C will oscillate? Yes, they will oscillate, but they will oscillate with small amplitudes, different amplitudes. You cannot say the word maximum. Maximum is only for the one that is the same as the original one. Okay, so pendulum X is displaced and released without touching the other pendulums. So pendulum X oscillates with a frequency of 2 Hertz. The other pendulums start to oscillate due to the oscillation of pendulum X lah, it's normal. So what is the meaning of amplitude? Is the maximum displacement. Okay, from original position. Okay, the amplitude is the maximum, this one from original position, or some books will say equilibrium position. Okay, daripada kedudukan equilibrium, keseimbangan. Okay, so the maximum displacement from the original position or the equilibrium position is amplitude. Okay, so which amplitude will oscillate with the maximum amplitude? It will be B lah. Okay, state Y. Okay, then you can say lah, okay, the length of B is the same as X. Okay, the length of B is the same as X. So you can mention that. Okay, yeah, sorry. Okay, the length of B is the same as X. The easiest lah, okay, the easiest reason. Again, everybody, this is the reason, and the next question will be phenomenon. Okay, so the phenomenon is called resonance. What you don't want to write now, okay, what you don't want to write is the reason is resonance. okay, which is also actually a possible answer, but you have to be smart about this lah. Okay, if the reason is resonance, then apalah phenomena kamu mau tulis kan? You can't write the same answer twice. So we have to be smart about this. The phenomena is resonance, which is actually also the reason. But the reason is that the length of B is the same as the length of X. Okay, B and X are the same length, so that's why it will oscillate with maximum amplitude, and this is called resonance. Kalau contohnya lah kan in the exam, there's only B1, okay, which pendulum oscillates with the maximum amplitude. And then B2, state one reason. Tapi dia tidak tanya B3. Dia tidak tanya soalan C. It doesn't ask you for the phenomena. Then you can write the resonance answer in here. Okay, if they don't ask, name the phenomena. But in this question, you have to be smart. You cannot write resonance for B2 and then resonance for C again. You cannot lah, because one is asking for the phenomena, one is asking for the reason. But if they don't ask for the phenomena, they ask for the reason saja, you can write resonance. Okay, totally not a problem. Should be okay. Okay, cuma dalam soalan ni dia minta phenomena, so you have to give a different reason. You cannot write resonance twice. Okay, calculate the period of oscillation for pendulum X. So period is 1 over frequency lah. Frequency is given as 2 Hertz. So 1 over 2 will be 0.5 and period is in seconds lah. This is a very easy question. Okay, 1 mark. Okay, the other day when we were doing the Terengganu paper, this question came out also, right? The Tacoma Bridge. Okay, and now we're seeing it again. So maybe it's a sign lah. Maybe. Okay, maybe it's a sign. Dua negeri sudah mengeluarkan soalan ini. Okay, I'm just saying maybe. I'm not saying it is a sign. Okay, but it'd be good for us to think about this question. So based on the phenomenon, explain how this tragedy happens. Okay, so this is the important thing lah. Okay. So what actually is not mentioned here is that the bridge, okay, the bridge collapsed because of the wind that was blowing. So ini kelemahan soalan inilah. Sepatutnya dia cakap pasal itu angin, bah. Sebab our jawapan kan mesti ada angin ini. Okay, kita punya jawapan mesti kena sebut pasal itu angin. So there is a slight problem with this question because they should tell you about the wind. Then you can use the wind dalam kamu punya jawapan. Okay, but since we are talking about this question and this is the second time this question has come out, it's good for us to talk about the why this happened lah. Okay, so the frequency of the wind, okay, is the same as the natural frequency of the bridge. Okay, first point. Okay, the frequency of the wind is the same as the natural frequency of the bridge. Okay, the second point, resonance. Oh, sorry, not resonance. Resonance occurs and the bridge oscillates with maximum amplitude. Okay, resonance occurs and the bridge oscillates with maximum and amplitude. Okay, the third point is not necessary, but just to kasih habis ni cerita lah. Okay, so the oscillation, okay, causes the bridge to sway lah. Okay, and collapse, because the word here is collapse. Okay, and finally collapse. Okay, so again, I will send this answer over, but if you are copying this, you might as well copy now. I will stay here for a little while. Okay, so what we need to talk about now is we need to relate resonance to the Tacoma Bridge. Okay, and actually, if you think about it, the answer is actually pretty standard one. Yang hanya berubah adalah the wind, yeah, and the wind and the bridge lah. Okay, the wind and the bridge is probably the only thing that changes. Okay, so another possible question for this one is the one yang the soldiers are marching on the bridge, and then as they are marching on the bridge collapsed. So a very funny story, but apparently it happened before lah. Okay, so if let's say they ask you to explain this, you can actually use the same explanation. The frequency of the marching. Okay, kalau in marching lah, what is marching? Pebarisan lah. Marching lah, marching. Okay, so the frequency of the marching, point number one, is the same as the natural frequency of the bridge. You can use the same exact model answer. Resonance occurs and the bridge oscillates with maximum amplitude. The oscillation causes the bridge to sway and finally collapse, and all the soldiers fall into the river. Blah 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 blah. But that is also another possible answer. Is also another possible situation where they will ask you for resonance lah. Okay, the marching one lah. Okay, apparently it's an urban legend lah. Ada yang cakap sebenarnya dia tidak berlaku dan ada yang cakap dia pernah berlaku. But in any other case, it is the same this one. Okay, another one is glass, and then the singer yang nyanyi note yang sangat tinggi sampai tu glass pecah. But actually that only happen, that can happen, but it's very hard to sampai that kind of frequency. But if you use our model answer here, you can use the exact answer to explain why the glass breaks. Okay, let's look at this answer. The frequency of the singer, okay, or the frequency of the sound from the singer lah, is the same as the natural frequency of the glass. Okay, point number one. Point number two, resonance occurs and the glass oscillates with maximum amplitude. We don't change anything except for the penyebab and the and the terkesan. And then number three, oscillation causes the glass. Okay, we won't say to sway lah. The oscillation causes the glass okay, to finally break. Sebab dia oscillate bahkan. So the oscillation causes the glass to break. That's it. Okay, so you can actually use this, like, this template now. Yeah, you can use this template to explain any situation that has to do with resonance. The three most popular one, number one is this Tacoma Bridge. Okay, number two is the marching, and then the bridge pecah. And then number three, which is actually the most famous, is the penyanyi yang nyanyi sampai ini pecah. Okay, so all you have to do is just change the penyebab dan yang terkesan. But everything else that I didn't underline in this answer over here, you can actually use it for, for this one. So it may be a good idea for you to memorize this lah. Okay, just change the penyebab dan yang terkesan. Okay, so pendulum X will stop oscillating after a few minutes. Okay, so it's called a damping process. Okay, so sketch the displacement time graph. Okay, so there are two things that we need to see when we are doing this. Don't just simply look at style. Okay, important thing is that the frequency must be same. So that means jarak dari sini ke sini, this distance and this distance, okay, must be about the same. Oh, sorry. Astaga. Here, sorry. Okay. From one cycle, satu pusingan kepada pusingan seterusnya kan, dia punya jarak mesti sama. That's why this is a 2-mark question. Because a lot of people, you know what they will draw? They will just draw like simply draw lah macam ni. Yang penting dia punya amplitude menurun. Ini 1 markah saja saya bagi. Why? Because the frequency is not the same. Sekejap besar, sekejap kecil, apa ini? Cincai lukis. So be very careful with this. Okay, we want to see, number one, the frequency must be the same, and number two, the amplitude must be decreasing because damping bahkan. So damping means the frequency doesn't change, cuma dia menjadi a lot smaller amplitude. Okay, but I think most people will remember that damping is amplitude decrease. So that's why I said most people will just cincai draw. Yang penting dia punya puncak sama lembah itu berkurang. But a lot of people will forget that the frequency has to remain the same also. So you need to draw 2 cycles. Okay, learn to draw this. Draw 2 cycles. Make sure that the frequency is the same. Jarak di antara 2 cycle itu kan, dia punya jarak lah. Okay, make sure that it is the same. Okay, because that is the second mark. So be very, very careful with this. Okay. All right. Oh, it's very interesting. Tiada soalan perbandingan bulan ni kan? They ask you to explain, but there's not really a comparing question here. Oh, could be like this. Okay, anyway, number 6. 6.1 shows 2 similar cargo ships sailing on the ocean. Again, Archimedes principle. We seem to be seeing this question a lot this year. So you might want to take note of this. So cargo ship A is without the load. Cargo ship B is with a load. The total weight of both the cargo ships is different. So what is the meaning of weight? Okay, last kan. Terus the weight. Okay, so the weight is the gravitational force. Okay, acting on an object. Okay, the gravitational force acting on an object is also known as the weight. Right, observe the diagram 6.1, 6.2. I'm going to give this answer straight away because everything is there. Total weight of A, so B will be more than A. The volume of water displaced, of course, B will be more than A because there is more of B in the water. So obviously the volume of water yang kena tolak ke tepi will be more lah. Okay, the buoyant force B will be more than A. Okay, and then relate the volume of water and the buoyant force. The bigger the volume of water, the bigger the buoyant force. Remember that this one must come first and then this one at the back. Jangan terbalikkan. The bigger the buoyant force, the bigger the volume of water. Tak boleh. It is you push the water aside, baru ada buoyant force. Okay. Now, one thing that a lot of people tend to confuse is dia nampak cargo B kan, dia lebih tenggelam. Kan, dia nampak cargo B lebih tenggelam. So in their mind, oh, mesti dia punya buoyant force kan lemah because dia tenggelam. Okay. Actually, that's not true. Remember, the buoyant force, okay, is determined by how much of the ship is in the water. Okay. And A and B are different because A is ringan and B is berat. So obviously B, yes, it looks like it's sinking more, but there is actually a bigger buoyant force acting on B. Disebabkan lebih banyak kapal yang termasuk dalam air. There is more of the ship in the water. So that produces a bigger buoyant force. Okay, remember this lah. Berapa banyak air yang kamu tolak ke tepi, itulah yang menentukan kamu punya buoyant force. You can push more water, you have a bigger buoyant force. Kalau kau tolak sikit saja, then you have a smaller buoyant force lah. Okay, so don't be confused with this. Okay, I suspect that a lot of people will answer number 3 wrongly lah. Compare the buoyant force. Dia nampak, oh, A kan timbul. Jadi A yang lebih besar lah dia punya buoyant force. Salah. B has a bigger buoyant force because it is more in the water. Calculate the buoyant force acting on the ship B given the mass of the ship B. This one, so F equals to rho Vg. I wonder why they give the mass though. Oh, sorry. But because it is in equilibrium, so it will be just the weight lah. Okay, so it is also equals to mg because the buoyant force, okay, equals to the weight of the ship. Why? Because the ship, it is sailing on the ocean. Dia bukan tenggelam lah, okay, dia masih terapung. Okay, so we use the principle of flotation over here. So all you have to do is just count mg, 15.05 times 10 to the power 13 times 9.81, and you will get this answer lah, 1.476 times 10 to the power of 15. Let me check. Oh, okay. 1.476 times 10 to the power of 15 newtons. Okay. Now, what will happen to the cargo ship B at the river bay? Okay, di Muara Sungai. Okay, give one answer, give one reason for your answer. Okay, so let's take a look at this. Originally is in the ocean. Okay, so you're talking about the comparison between ocean water and river water. Okay, ocean water and river water. So what we need to know is that ocean water is more dense and river water is less dense. Okay, and this is very logical lah. Sebab ocean water lebih, okay lah, how do I say this? It's not entirely true lah, but you can say it this way lah. So ocean water is very salty sebab dia banyak garam kan. And then river water is not so salty lah, so dia tidak banyak garam lah. That's why ocean water lebih tumpat sebab lebih banyak garam di dalam air itu. Berbanding dengan river water, which is not very salty lah. So it is less dense. Okay, and we have to consider how the density affects the buoyant force. F equals to rho Vg. Okay, so we find that the smaller the density of the water, the smaller the buoyant force. Okay, and so if the buoyant force is now smaller, because dia masuk ke dalam muara sungai sudah kan, goes inside the river bay, what will happen to cargo ship B? Cargo ship B will sink more. Okay, cargo ship B will sink more. Why? Because river water is less dense than the ocean. Okay, ocean produces a bigger buoyant force. That's why dia boleh timbul dengan lebih lagi lah. The weight has not changed, the weight of the cargo ship has not changed. What has changed now is the buoyant force because you're moving from ocean water to river water. So the less dense the water is, the smaller the buoyant force it is able to be produced. Okay, so this is a very good question. Okay, it really challenges us to think about Archimedes' principle and the factors that affect the buoyant force. There are actually two factors that affect the buoyant force. Okay, in the first situation, kita lihat berapa banyak kapal yang termasuk dalam air. So the more the ship is in the water, the bigger the buoyant force lah. Okay, but in question E, we are looking at the density. Okay, if the density, now the ship is the same ship, cargo ship B, but the density of the water has changed. So when the density decreases, the buoyant force also will decrease. Walaupun the berapa banyak dalam air itu kan adalah tetap sama. So because of that, the buoyant force decrease, so the weight will become slightly more than the buoyant force lah. So it will sink. Okay, dia akan lebih tenggelam lah. Okay, because the river water is less dense than the ocean water, sorry. Oh, the Dead Sea. The Dead Sea is the one yang sangat-sangat tumpat bahkan. Is very, very distant. Yeah, so if you change to the Dead Sea is very, very, very dense. Sebab dia banyak betul garam. So the buoyant force will increase lah. If the buoyant force increase, then the cargo ship B will float even more. Okay, so you can say that float more. Oh, that's a good question lah, actually. Assuming that you're saying Dead Sea lah. Dead Sea is the one in the mana itu, somewhere in the Mediterranean. The one that is so dense, okay, dia sangat banyak garam di sana that anything that goes in there will automatically float. Tak payah pakai pelampung pun, kamu boleh float sudah. Oh, that's a very good question. Actually, it's very good. Okay, so what will happen if cargo ship B goes into the Dead Sea? So the answer will be it will float more. No? It will float more because the buoyant force, it is more dense than ocean water, and so it will produce a bigger buoyant force. Okay, so pretty much the same reason. Oh, that's a very good question. Thanks for that question. Okay, 7.1 shows a 1500 kilogram van traveling at a speed of 15 meters per second. This is a momentum question lah. Okay, so just to remind you, momentum is mass times velocity. Okay, momentum is mass times velocity. So traveling over here after the collision, both of the vehicles get stuck and move together. So this is a inelastic collision. Okay, dia lepas dia berlanggar terus dia bergerak sama-sama. Okay, so they don't go other ways now. So define momentum. Momentum is the product of mass and velocity. Okay, the very standard definition lah. So state the principle involved in the above collision. So it is the principle of conservation of momentum. Okay, so calculate the velocity of the van and the car after collision. Okay, so we have to calculate it before and after lah. So this is before. Okay, before, the momentum here is 15 times 1500, which is 1500, which is 22,500. This one is negative 20 times 1000. Why negative? Because the velocity is to the left. Okay, so this is one very important thing that you need to remember. Even in momentum, the direction matters. We established this in question 1. Okay, momentum is a vector quantity. So the direction matters. So this will be negative 20 times 1000. This will be negative 20,000. Okay, so the total before, okay, is 22,500 plus negative 20,000. Okay, which will give you 2,500. Okay, now after the collision, okay, sorry, so before is 2,000. Okay, before is 2,500. Okay, yes, momentum, kilogram per meter second. Okay, after, if we consider this one after, both this one, 1,500 and 1,000. So 1,500 and 1,000 kilograms will move together. Okay, so the momentum will be 1,500 plus 1,000 times with the velocity after. Okay, so it will be 2,500 V. Okay, now according to the principle of conservation of momentum, before equals to after. So 2,500 equals to 2,500 V. So V will be equals to 1 meters per second. That means these two cars, lepas diorang berlanggar, akan berjalan ke sebelah kanan. Because the 1 is a positive number. Okay, if the 1 is a negative number, then it's going to go to the left. But since our V is a positive number, so the 1 that means that both the cars are going to go to the right lah. And it's very logical lah. Okay, if you think about it, it's very logical. The 1,500 is so much bigger than the 1,000. So walaupun dia berlanggar, walaupun yang kereta yang 1,000 kilogram tu dia 20 meter sesaat, it's faster, but it cannot compensate for the super huge mass difference of 500 kilograms. So of course, dia akan tertolak ke belakang lah, mengikuti direction of the van. Okay, so you want to do this lah. Now, when it comes to principle of conservation momentum, I like to do everything separately lah. Saya kira sebelum saya kasih jumlahkan, saya kira selepas saya kasih jumlahkan, baru saya kasih sama, which is what I'm doing. Okay, I calculate everything before and then I total it. And then after that, I calculate everything after and then I total it and then saya kasih sama. Okay, the standard formula lah for like inelastic collision is M1U1 plus M2U2 equals to M1 plus M2V. Okay, which is why I want to bother memorizing this lah. Because principle of conservation of momentum is total momentum before equals to total momentum after. So you count before, you count after, then you kasih sama. You find whatever it is that you need to find. In this case, is the velocity. Okay. So it's up to you which one you prefer. Like if you're used to this method, yang formula panjang-panjang, which is not given, this formula will never be given. So inelastic, elastic explosion, all these formulas are not given. If you want to know, you have to memorize them lah. Okay, which is why saya selalu cadangkan use the before and after. Kasih total before, kasih total after, then you kasih sama. Okay, I would recommend that. But if you want to use the formula, make sure you memorize it lah. Okay, the jet engine of an airplane. So this is question 7. This is mau buat pilihan lah kan. Okay, the jet engine of an airplane uses the principle of conservation of momentum to produce a forward thrust. Okay, so we have 3 types. So we want to talk about the size of the combustion chamber, okay, which is over here, either small or big, okay, which we don't know. The size of the opening exhaust, okay, which is here, big opening or small opening, okay. Oh, sorry. And then find, oh, only these 2. Okay, fine. But size of the combustion chamber. Of course, the size of the combustion chamber must be big lah. Okay, so we want a big combustion chamber. Oh, terus tiada pilihan sudah ini. Okay, we want a big combustion chamber so that more fuel can be burnt. Okay. The word combustion, kalau kau tengok dalam bahasa Melayu kan, is pembakaran. Apa yang dibakar? Bahan api yang dibakar, which is, kita punya minyak lah, petrol lah, petrol or diesel. Itu yang kena bakar. So the bigger your combustion chamber, you can put in more fuel. Okay, kamu boleh letak lebih banyak bahan api untuk dibakar. Tidak payahlah kamu sikit. Bukannya kamu jimat untuk apa bahkan. Sebab kita mau, okay, why do we want more fuel to be burnt? Because we want to produce a big forward thrust. Yang kita sedang tolak ke depan, it's not a paper airplane, no, it's an airplane, So you need a very big momentum, okay, in order to do this. Okay, then secondly, the size of the exhaust opening. Okay, the size of the exhaust opening has to be a small opening lah. Okay, because if you have a small opening, okay, then the gas will be released. The exhaust gas can be released. Okay. Sorry, hold on. Okay, can be released, okay, at high velocity. Okay, so remember, kalau dia punya lubang exhaust itu sangat kecil, the gas can be, this one lah, it will, so dia sangat kecil kan, so that means dia akan push back with a bigger velocity. Kalau dia punya ruang sangat besar, if the exhaust hole is very big, no need to faster go out lah kan, just slowly go out so can lah. So we don't want that. Okay, which is I always say this lah. Yeah lah, I always say like, when you 放屁bila kamu kentut bahkan, the one with the most noise unfortunately is the one with the smallest. This is a very bad example lah, but yeah, it's true. Kalau makin kecil kan kamu punya lubang gitu kan, makin kuat lah kamu punya gas itu terkeluar. Okay, so yeah, it's a very bad example, but it's easy for us to remember lah. Okay, so we want a big force, so we want to have a small hole so that the exhaust gas will be this one lah. Okay, so obviously the best choice here will be R. Okay, so R will be the best choice. Don't have to say the reason. Okay, but last question. So 2 types of pot and its characteristics. So this is kind of set already lah. Selalu ini kena tanya ini. So you have clay over here, specific capacity. Okay, remember again specific capacity Small specific capacity means faster jadi panas. Okay, very important thing. Big specific capacity means takes a long time to get hotter. Okay, dia boleh simpan lebih banyak tenaga lah. Okay, now what is meant by specific heat capacity? Okay, is the heat required to raise the temperature of a 1 kilogram substance by 1 degree Celsius. Okay, the heat required to raise the temperature of a 1 kilogram substance by 1 degree Celsius. The 1 kilogram and the 1 degree Celsius is a very important one. Okay, wajib ada. Okay, so based on table 2, state the characteristics of the pot if it is used to cook food at faster rate. So we want to use the pot to cook food at faster rate. So the material of the pot, so this is very interesting. It's like you're supposed to be given a choice, but you don't really have to. Okay, so the material of the pot, okay, obviously it will be copper lah. Okay, so it will be a copper pot. Okay, why? Because the specific heat capacity is lower. Okay, you can say that lah. Okay, so lower specific heat capacity, because lower specific heat capacity means the pot will get hotter faster. Okay, now depends on whether you can remember this during the exam lah. Saya lebih gemar if you use the words specific capacity in your answer, because that is a more physics answer. If you say we want to use copper because copper gets hotter faster, dia lebih cepat panas. Technically, it is true, but this is a physics paper. Okay, so you want to try to kaitkan perkara-perkara yang berkaitan dengan physics lah. Adakah jawapan kamu get hotter faster itu tidak akan diterima? Kalau saya tidak akan terima lah, because you know they already give you specific heat capacity. You should use the words. So if you can remember, better to use lower specific heat capacity daripada perkataan get hotter faster. Dia lebih cepat panas. Or cook the food faster. Ini saya rasa memang kalau saya tidak akan terima lah. Okay, because I feel that the lower specific capacity is very obvious. The answer is there. So you try to use as much physics as you can in a physics paper. Okay. So the material of the handle, okay, so we want to use the material of the handle, either a clay handle or polymer handle. Obviously, we want the polymer handle. Okay, so we want a polymer handle. And why do we want a polymer handle? So that, you know, the specific heat capacity is lower, or it is a good heat insulator. Okay. Actually, just now is copper, lower specific capacity atau good heat conductor. Also, I will accept because heat conduction, heat conductor bahkan dia ada kaitan dengan physics lah. So it's definitely a better answer than cook food faster or heat up faster, which is the kind of answer we want to avoid lah. I'm not saying that it's wrong, but I just say that better to use a physics related answer. So if you say good heat conductor, I will probably accept. Okay, likewise, polymer for the material, the handle, polymer or plastic, okay, specific capacity is lower, it is a good heat insulator. Okay, the mass of the pot, ini very easy lah. Okay, smaller mass of the pot. Remember everybody, sorry, remember, don't write the number. Okay, write the higher or lower, smaller or bigger. Okay, why do we want a smaller mass of the pot? So that it will be lighter. Okay, lighter, easier to carry around, easier to throw at whoever is making you angry, or whatever that you want to do with pot lah. Okay, so lighter is always better lah. Okay, the copper pot is heated up by a heating plate of power. This one, calculate the time taken. So this is the PT equals to MC delta theta. Okay, so increase the temperature 50 degrees Celsius, so it is here. Okay, this is copper pot, so we use the C for the copper, which is 390. Okay, the mass is 2.5 kg. So everything is given in the question lah. So 2.5 times 390 times 50 degrees Celsius, and then the power is 800 times the time. So you get the time equals to 60.94 seconds. Okay, for those of you who are in 5SA, you should remember this formula. You know why? Because kita pinjam itu ceret elektrik daripada entah siapa bahkan. And then this one, and then lepas itu, saya tidak ingat sudah siapa yang tidak puas hati itu buat balik supaya boleh dapat itu value of C yang paling dekat dan boleh menang nasi lemak. So don't forget this formula. Okay, especially if they are giving you the power. If it is a heat question and other power terlibat, remember this. PT equals to MC delta theta kalau dia melibatkan peningkatan suhu, atau PT equals to ML kalau dia melibatkan perubahan fasa, changing of phase. Okay, ice become water, water become vapor. This PT equals to ML, because PT is also the formula for energy. This one is also the formula for energy, heat energy lah. Okay, so don't forget this. Okay, this is semua lah, don't forget. Okay, so that's it. That's it for this one. Okay, I want to answer one last question before we call it a day. And I think this question is so good. This is a very good question lah. Okay, it's so good that I feel that I need to answer this and put it up on YouTube so that people listen. So quite a lot of people have asked me this question. Okay, this is an objective paper question. I don't know which negeri this is from. I think it's one of your negris. You can look at it. But if not, you can take a screenshot of this, and I want to answer this together with you. Now, when a photoelectric material is shone with a blue light of wavelength lambda equals to 452 nanometers, okay, a photoelectron with 0.75 EV, okay, EV, not joule, okay, is emitted. So the question is, what is the threshold wavelength? Okay, so we we backtrack a little bit. What we know, okay, what we know from, oh no, I need to find this empty page. Hold on, do I have an empty page? Okay, I think okay. What we know from the photoelectric effect is the total energy, okay, equals to the work function plus the kinetic energy. Okay, this is, okay, so again, this is the total energy, okay, this is the work function, and this is the kinetic energy. Now, setiap satu ini dia ada pembahagian sendirilah. According to Max Planck, the total energy is E equals to HF. Okay, this is energy of a photon. So the total energy is E equals to HF. The work function, okay, is H times the threshold frequency. Okay, and then of course kinetic energy will be half mv squared lah. Ini tak payah fikir lah. Okay, half mv squared or other similar formulas. Okay, now selain daripada itu, we also need to remember that since we are talking about light, okay, we have to talk about the wave equation, which is V equals to F lambda. Tapi because V is the speed of light, so C equals to F lambda. Therefore, F equals to C over lambda, which makes this formula becomes E equals to HC over lambda. Okay, saya mula dengan ini dulu. The basic stuff that you need to know about the photoelectric effect. The total energy equals to the work function plus the kinetic energy. Sebab when the photon is shine, okay, it needs some energy to release the electrons, and then the remaining energy akan kena convert pergi kinetic energy yang akan menggerakkan itu elektron. Okay, now coming back to this question, what is given to us is this very, very strange values. You are given the wavelength, okay, 452 nanometers. And then the photoelectron with this one is emitted. Okay, so this one is actually our kinetic energy. Okay, it's actually our kinetic energy. So the question is, what is the threshold wavelength? Threshold wavelength ada kaitan dengan work function. Kan? Because threshold frequency So let me write this again. Equals to HC over lambda threshold. Okay, if I follow this, HC over lambda threshold. Now, if you look at both these formulas, okay, we can either use HF and HF naught or HC over lambda and HC over lambda naught. Okay. Now, if we look at the information given, we are given HC tau. Oh. This is a very, very interesting question because biasanya dia akan bagi kita H. Tapi ini kan, dia bagi kita HC and look at the unit of HC is EV nanometers tau. It's not even joule meter, you know. It's EV nanometers. Okay. So where have we seen the nanometer? The nanometer is seen in the wavelength. Okay. Which tells us that actually we don't even have to convert anything, you know. Tak payah tukar itu nanometer pergi meter. Tak payah tukar itu EV pergi joules. Because our constant values are using the units that we already have. Okay, so this is like okay, be very careful with this lah. Okay, so this is how I would do this. I would start with the photoelectric formula, okay, which is the total energy equals to the work function plus the kinetic energy. Okay, now the total energy is Hc over lambda. This is Hc over lambda naught plus 0.75. Okay, mana saya dapat ini? Saya sudah terangkan di sini lah. Okay, so take a look at this later. Okay, so then I substitute everything in. Hc is 1.243 times 10 to the power of 3. Okay, sorry, I got no space, so I will write it here. Sorry. Okay, 1.243 times 10 to the power of 3 over 452. Okay, over lambda. Saya tak payah tukar pun, I don't have to change the nanometer to meter because my Hc is already in nanometers. So don't make my life difficult. Okay, equals to Hc over threshold frequency, threshold wavelength yang kita mau cari. Okay, so the same thing lah. 1.243 times 10 to the power 3 over the threshold wavelength plus 0.75. Okay, then you calculate this. Okay, yeah, you calculate this and you will get the answer 621.5. This is the answer lah. Okay, but the reason why I'm discussing this question, number one, is because a lot of people have asked me how to do this question. Okay, and number two is I want to expose you lah, okay, to the fact that sometimes, especially quantum physics okay, especially quantum physics, we have to pay attention to the units. Okay, pay attention to the units, and we have to look properly and see. Okay, we have to look and see whether we need to change the units or not. Okay, if you notice this one, the tenaga bukan dalam joule, it's in EV. And Hc is given as EV nanometer, and that is actually a clue for us. Oh, saya tidak payah tukar itu. You know, I don't have to change the unit to meters because it's already in nanometers. Okay, so in a way, actually, this question has been made easier lah. Dia sudah dijadikan lebih senang untuk kamu. Okay, if you look at the calculation kan, it's like macam ni saja. Kamu, of course, you will have to understand how this works lah. You know, but if you think about it, there is no conversion. Tinggal kau kasih masuk saja. Okay, and then you can calculate the threshold wavelength. Okay, but I wanted to expose you to this question, yeah, because a lot of people have asked me. I want to put it up on YouTube so that other people can also listen. If you know which state this question is from, it'd be quite good to let me know because I really don't remember which state this is from. But a lot of people have snapped this picture and showed to me. So can you please tell me? I don't know how to do this question. Okay, and I want to discuss this question. Such a unique question because kita selalu joule. Now suddenly got EV and then the nanometer also no need to change. And then the constant they give is Hc sedia ba. Usually H and then C, but H is don't know what value and then C is another value. then nanti kau darab sendiri. Ini sudah kena darab untuk kamu. It has already been multiplied for you. Way easier. Okay, so give this question a try. Give this question a try just to practice and see how to use Einstein's photoelectric theory. Okay, it's very good question. All right, so that's it for our sessions for physics. Okay.